All right, today I'm going to teach you something that is one of the absolutely most useful pieces of calculus that you will ever have. Okay? So, all right, Marcus makes an excellent point. Okay? What did you just say, Marcus? Please echo it. Forget the chain rule. Okay? The chain rule, wouldn't you say, was amazing to be able to take derivatives in first semester, right? Today we are going to use kind of the integrals version of the chain rule, and it's called substitution. So this is something that you will continue to use for the rest of your mathematics career. It is amazing. It is very straightforward. It is awesome. Okay. It makes me very happy inside. Okay. So look at this integral. If I give you just the integral of 3x squared, you'd say no big deal. But if I give you the integral of 4 plus x to the third to the fourth, you would say, well, gosh, if I'm going to do that, we have to FOIL it out and take the antiderivative. I understand that. But now we have 3x squared times that. So what are we going to do? And here's what we do. We use substitution. The substitution rule says I define a substitution for the variable u. And I choose what's on the inside. Yes, there are correct choices and incorrect choices. For 95% of the problems you will do, you will simply look at what's being taken to a power and choose that as the inside portion. This is why I choose that to be u, because then I take the derivative of the inside. Note that the chain rule requires the derivative of the inside times the derivative of the outside with the inside left alone, correct? So when I take the derivative, so the derivative of u is du, the derivative of 4 plus x to the third, what's the derivative of 4? Simply 3x squared is the derivative of the entire piece times dx, okay? So when we take the derivative, we will write the dx on the end, okay? Watch. If I rewrite the integral, instead of writing 3x squared dx, what can I write instead? Du. Instead of writing 4 plus x to the third, I can write u. So I have substitution pieces that are now in place. I will rewrite the integral. Instead of 4 plus x to the third, I will write u, and u is being taken to what power? The fourth power. Instead of writing the 3x squared dx, I will simply write du. What is the antiderivative of u to the fourth? U to the fifth over 5 plus c. What do you think I do with the u? Substitute the 4 plus x to the third back in. That's the antiderivative. Well, we are going to verify that it is in fact correct. How would I verify that that is in fact the correct answer? Take the derivative of it. In order to take the derivative, what rule would I have to use? If there was an x on the bottom, I would use the quotient, but it's simply a constant. It's a 1/5. So what I'm going to do is I'm going to use the chain rule. The chain rule will say u is 4 plus x to the third. The outside is u to the fifth over 5 plus a constant. What's the derivative of the constant? 0. What's the derivative of u to the fifth over 5? U to the fourth. What's the derivative of 4 plus x to the third? 3x squared. Multiply them, and I get 3x squared times the quantity, 4 plus x to the third, to the fourth power. You don't have to verify it every time. I just did it once for teaching purposes so you could see how closely connected the substitution rule is with the chain rule. Yes. Well, yeah, whenever we had a dx, we never worried about that, did we? Again, the dx is representational of the infinitely small width of the rectangles. Yes. And when we take the antiderivative, we saw that it simply went away. Thank you for asking the question. I'm teaching you a technique that is extremely useful. However, make just a simple change. Instead of a 3x squared, have 3x to the third, and then we create a large issue for ourselves. Change it and have it, 4x squared, and it's not a big issue, but it is different. Substitution is a technique that works in many cases. However, there's a ridiculous number of situations where it does not work very well. This is an integration technique, one integration technique. There are many, many others. This is the most useful one. To answer Taylor's question, how do you know? You don't. You practice and become very good at it. Like I said, Isabel came to me the other day with a question. She said, what is the antiderivative of 1 over e to the x times e to the x plus 1? And, that's a good question. I can't remember exactly what the answer is, but I did it the other day. I think it's the natural log of e to the negative x minus 1, I think is the answer. But I can't remember for sure. But we had to set up a couple different methods to do it. It was a challenging problem. So I just want you to know that this is a difficult part of calculus. But this rule is the most useful one that you will use moving forward. And so we go to work. We get to Beau's point in this problem. We say that u is equal to what? However, du is equal to 8x dx. I don't have an 8x dx. I have a 7x dx. What's the derivative of 4x squared? See, it's amazing because the same thing happened last hour, or second hour, and I never anticipated it. When I wrote 3x squared, people didn't understand, even though I said that we were actually taking the derivative of that. Yeah. No, they didn't know. They thought we were just grabbing it. So that's why I created these two types of problems. But I never actually anticipated that that would ever be a question. So you learn as a teacher. I don't want an 8 in front of there. Instead, I want a 7. So how would I get rid of the 8? I would divide both sides by 8, right? And then you would multiply by 7. So what's the same thing as multiplying by 7 and dividing by 8? So if I multiply by 7 over 8, multiply by both sides by 7 over 8, I get 7 over 8 du is equal to, those cancel, 7x dx. So what that tells me is that instead of simply substituting du, I substitute 7/8 du. The u is still just 4x squared minus 3. So I will write this as 7 over 8 times the integral. I'm going to put the 7/8 on the outside. I'll put the du back here. And being I wrote the 7/8 and the du, what can I cross off from up here? What have I used up so far? The 7x and the dx. So instead of 4x squared minus 3, what do I put in its place? u to the third. So my new integral only has u's in it. You can't have u's and x's left in the integral. It doesn't work like that. Okay? So if I want to take the antiderivative, what's the antiderivative? U to the third. U to the fourth over 4. I'll multiply it by the 7/8. So I get 7 times u is 4x squared minus 3 fourth over 32. And we have to write plus a constant. There you have it. When you come back, we'll practice a couple problems. Make sure you got this, and then we'll get to the rest of our notes. Tomorrow, you'll have a full day to work. He hasn't even started. So, all right. Or, yeah, just, okay, there we go. All right. So we flip back. Let's do some more problems, okay? So what we'd like to do is we'd like to get through, a few more during this hour, and then we'll finish up a couple tomorrow, and you'll have time to work. But second hour, we had about 58 minutes of class, so we were able to get through all of this stuff. We'll probably get through about, 3 or 4 more problems. But well, anybody want to guess what u is in this situation? It's the square root of x. Because it's on the inside of the cosine. So often I ask myself, if I were to take a derivative, what's on the inside for the chain rule? So what u would be for the chain rule, and in this case, it's not always the case, but it's a good starting point. So du is equal to, what's the derivative of 1 over 2 roots of x dx? So I have a square root of x in the denominator, don't I? But I don't have a 3 in the denominator, I have a 2. And I have a negative 2 up top. If I want a negative 2 up top, I'm going to have to multiply through by negative 4. A negative 4 over 2 would create that negative 2, so I'm going to multiply through by negative 4 over 3. So negative 4 over 3 du is equal to negative 4 over 3 times 1 over 2 roots of x dx. And you can see that the negative 4 over 2 will reduce to negative 2 over 3, right? So it's nice to look at the pieces and see that negative 2, 3 roots of x, and dx are all taken care of by negative 4 thirds du. So negative 4 thirds du. And what? Did the cosine go away? No. So I have cosine of what? U. Well, that's easy. The antiderivative of cosine is positive sine times negative 4 thirds is negative 4 thirds sine. And u is the square root of x. Let's see. Done and done. What do you think? Which part? Tell me where. Right here? So I got the negative 4 thirds right there. The du right there. I crossed off the negative 2, the 3 roots of x, and the dx. So I just have to replace cosine, which is there. It says square root of x. That's u. The antiderivative of cosine is sine. Du serves as part of the substitution, but other than that, it really, yeah. But it is important because there are times where I'm doing an integral, and there's been times I can't work around the du, and if I could get it to go away or find one, then I'd have an easier time. So it is important. It is important. Okay, all right, so a lot of times I ask myself, what would I take the derivative of to get something that's left? Again, if you take the derivative of the square root of x, you get 1 over 2 roots of x. So that's why it was nice when we saw the square root of x to choose that. Now, what do you take the derivative of to get something else up here? What do you take the derivative of to get secant squared? Tangent. Not tangent squared though, right? So this would be a very difficult problem if we didn't change it. We are not ready for a problem like that. We will do 4 plus tangent of x, that quantity cubed, times secant squared of x dx. We're not ready for that problem. I miswrote it when I put it in there. So we have this, and so what I look for is what do you take the derivative of to get something else? Well, if we take the derivative of tangent, we get secant squared. But it also works if I take the derivative of 4 plus tangent, I also get secant squared, don't I? Yeah. So I will choose u to be 4 plus tangent of x. So du is secant squared dx. Looks like everything's taken care of, isn't it? So now I have my integral u to the third du, which is u to the fourth over 4 plus c. 4 plus tangent of x to the fourth over 4 plus a constant. I didn't get that plus. There we go. Is that okay? Yeah, so your calculus textbook, so there's a viola there, and the viola you gotta. See that? There's no book in the band room because we stole all of them. That's all right. Anybody want to make a choice for this one, number 5? Very good. U is 1 minus x squared. So du is negative 2x dx. You don't have a negative 2x dx, but you do have an x dx. I want to get rid of the negative 2, but I want to add a 3. If I multiply by a negative 3 halves, will that create my positive 3x dx? Yes. Negative 3 halves integral. By making this substitution as negative 3 halves du, what do I get rid of? The 3x, the dx. So 1 over the root of u du, which is the same thing as negative 3 halves times the integral of u to the negative 1 half du. U to the negative 1 half, antiderivative, u to the 1 half over a half, or 2 roots of u. Negative 3 halves times 2, negative 3 roots of 1 minus x squared plus my constant. What do you think? A little bit louder, Taylor, please. What is it that you don't like about it other than it's amazing and awesome? Okay, all right. Yes, beauty is in the eyes of the beholder, so leave it at that. Number 6, u is equal to what? X squared plus x minus 1. So du is 2x plus 1 dx. I don't have a 2x plus 1. If I multiply through by 2, I'll get 4x plus 2. 2 du is equal to 4x plus 2 dx. That was a nice trick there. Just, you know, if it was 4x plus 3 instead, that, I mean, it wouldn't have worked, would it? So that would have been very challenging then. So you're thankful for, you know, the way it works out here. So I take the integral, I have a 2 and I have a du. Since this complete substitution goes where I have a 1 on top, and on the bottom I have u to the third. Or 2 times the integral of u to the negative third du. What is the antiderivative of u to the negative third? So it's u to the negative 2 over negative 2, right? Or 1 over negative 2 times u squared. So we get 2 times 1 over 2 u squared. Sorry, it's negative. Twos cancel. Negative 1 over x squared plus x squared constant. No. But if you would like to, that's fine. Who can tell me something interesting about number 7? What's the derivative of e to the x? E to the x. So if I take the derivative e to the x, do I get e to the x plus 1? But if I take the derivative e to the x plus 1, I get e to the x. Isn't that sweet? So u is e to the x plus 1. Du is equal to e to the x dx. That was sweet, because those go away, and e to the x plus 1 I'll replace with u. Yeah, u. So I have the integral of 1 over u du. What's the antiderivative of 1 over u? U to the 0 over 0? What'd you say, Emerald? Emerald, say it louder, please. Take ownership of your... Come on. Give you a chance. I'm not telling you right. Just take a chance on being a genius. The antiderivative of 1 over u is natural log of u. Remember? You take the derivative of natural log of x, you get 1 over x. So, natural log of u plus c. So we plug u back in and we get natural log of e to the x plus 1. So I will give you the book page, and tomorrow we'll just do one example. That way you could get started. Okay? Your assignment is, so you could get started if you want, is page 366, 1 through 23.